Okay, I got 2 o'clock. Let's get started so we have plenty of time for Q&A at the end of this. This is the meeting of the VMware SIG at the first day of KubeCon, and we're here to talk about storage when you run Kubernetes on the vSphere hypervisor. I'm the blue picture, that's David. We both work for VMware on Kubernetes. And I'm chair of the VMware SIG, which is a group that hosts a meeting place for both developers of Kubernetes code related to running Kubernetes on vSphere, as well as users who are running Kubernetes on top of the vSphere hypervisor. And this applies to anybody running Kubernetes, whether it's a VMware distribution or another distribution like Red Hat OpenShift or just pure open source upstream Kubernetes. Our agenda today is we're going to go, even though this was advertised as an intro, so this maybe is getting towards a gray area, getting into deep dive and what we're going to cover here. So I'm going to rush through kind of the history of how external volumes are supported in Kubernetes. We're going to go briefly into the situation with what's called the legacy plugin, and I'll get into what that means. Then move on to the container storage interface, which is the future of Kubernetes and external volume mounts, maybe the future and the present. And we'll get into the specifics of the CSI driver for vSphere and wrap up with operation best practices and a demo by David. We'll touch briefly on migration from in-tree to out-of-tree and troubleshooting. So external volume mounts, what are they? How do they work? Why are they useful? They're useful for running stateful apps in Kubernetes. You know, the 12 factors said everything should be stateless, but the reality is that that was just declaring that the hard parts are somebody else's problem. And people want to run stateful apps inside containers and have them managed by an orchestrator like Kubernetes. And these external volume mounts are the key to managing to do this. You know, the way containers work, if you don't use external storage, the life of your storage is potentially the shorter of the life of the pod or the life of that node that it's running on. So if you kill it, your database is gone, like potentially forever. Not a good story. So being able to schedule pods at a number of different locations and still have them linked up to their storage is valuable just to address life cycle, but it also is potentially valuable to address high availability and scale. You know, if you were only using direct attached storage and whatever physical node was hosting your Kubernetes worker node, there's a physical size limit on how big that can be. There are people with databases that need to go well beyond that. And these external volume mounts are the key to extending your lifestyle, your life cycle, your lifetime, your potential maximum size. And that's how you bring this about. The goal of this Kubernetes persistent volume abstraction was to provide an identical interface everywhere to abstract out the storage so that you can't tell where you're running. If you do this right, you should be able to write an app that can't even tell where it's running so that it's cloud native, meaning I could move this app unchanged, run it in the AWS public cloud, the Google public cloud, the Azure public cloud, or take it on-prem, running on a vSphere hypervisor, for example, and nothing in the app changed. So the persistent volume abstraction is designed to allow that kind of thing to happen. The original design with Kubernetes put these volume plugins. The volume plugin was just an adaptation to do the actual code that provides an abstraction layer so that storage type A looks like storage type B, and you achieve this potential portability. In the early days of Kubernetes, all of these volume plugins were built into Kubernetes itself, right in tree. They were in the Kubernetes GitHub repo. And as Kubernetes got more popular, bigger, and more people wanted to host these storage plugins, it essentially was on the road to becoming unworkable. There are a couple bad things with having them in tree. If I might move to a certain cloud or underlying provider, and I'm only using one or two of these storage plugins, yet the rest of the code happens to be built in there. The code actually ran as part of Kubernetes itself, so there's a potentially, if there is a security flaw in the code in one of these drivers, it isn't as well isolated as it might be from Kubernetes itself. A third issue with having them in tree is that you've tied the release cycles together. So suppose I want to add a feature to the storage plugin, or there's a bug and I want to fix it. I can't get that binary out there to the users without doing a new release of all of Kubernetes, which is gated by a lot of other things, because at any given time in a patch cycle, one storage provider isn't likely to be the only bug fix in the queue, and they're not going to do one of these Kubernetes releases every 5 minutes. So it tied the release cycles together. By moving these storage plugins out of tree, the storage adapters can be worked on completely independently, and a user can install only the bare minimum of what they particularly need. And if somebody publishing one of these external storage plugins chooses to publish it in this week, that can be done independently of Kubernetes. So there doesn't need to be a Kubernetes re-release to get that out there to the world. So these originals were built in, and there was an option called a flex driver that technically wasn't built in, but it was a little bit limited in that the flex driver is exec'd out to a CLI, and it was limited in the available features, and those weren't deemed to be the perfect solution for moving out of tree. So the in-tree version of the plugin for vSphere was called Project CatchWay. It's been out there since 2017. It's declared GA today. I've talked to some of you in the audience, and the recount, I heard some stories of some issue, and if you're having one, you're not the first one, but all software has bugs. We'll talk about some of these potential issues later, but we do have this in-tree one that is still in the Kubernetes release, and the Kubernetes project has kind of given the warning signal that at some point, and they haven't declared an actual cutoff date yet, at some point these things have to go out of tree. But for now, you're fine to use the in-tree one. I don't think it's likely to go away for at least a year. One thing that comes up in the meetings of the VMware SIG or in our Slack channel is that people are noticing that when this thing starts up, you do get a deprecation warning right now. And I don't know how many people have asked, do I need to worry about this right away? I'm seeing this warning. And the answer is, no, it's just giving you this clue that sometime in the next year, something might change. And we are going to talk about what the migration path will be later in this talk. The one thing you have to be aware of with this in-tree thing, even though it works, is that new features have been frozen in this thing since the end of 2018. So there is this out-of-tree driver, and that's where investments are being made in supporting new features. So it's out there, it's a GA release, but if you're doing a greenfield Kubernetes deployment, you might want to look at the out-of-tree as an option. So this out-of-tree project is called the Container Storage Interface, and it moved to GA in Kubernetes in version 1.13. And this is actually not something deemed to be in the Kubernetes project itself. You will find related code Vlad here in the front row actually works on some of that enablement. The reason it's not deemed to be part of Kubernetes is that there are other orchestrators out there, Apache, Mesos, Docker, Cloud Foundry, that also support these same volume plugins. So people in the community who write these volume plugins were being faced with the scenario where they were having to do implementations of different storage plugins for all of these platforms. You know, I think if you went to the keynote today, there was essentially a factual declaration that Kubernetes seems to be out there ahead of the other orchestrators in the popularity race. But this work has been underway for well over a year, and a lot of storage providers really wanted an industry-wide standard to evolve so that they wouldn't have to do 4 times the work to support all of these different platforms. So CSI is being run with a separate organization shepherding the spec for this. Then Kubernetes itself works on code that first there's groups of people who negotiate the CSI interface and feature set. Then people within the Kubernetes project will work on enablement, with some of that code being in tree, but the particular storage provider parts of this being out of tree. And it goes through a cycle when new features are added, where the new feature related to storage might have people negotiate an interface expansion. Then Kubernetes has to support that interface. Then the storage plugins actually implement the out-of-tree end of this. So the CSI for vSphere first release, the alpha is out right now today. And there's been alpha code out. David, that's been since last December, right? A beta is projected to be released in June, so sometime within 4 weeks-ish, and GA in July. The features, it uses VM-independent volume management, which the in-tree did not. And if you're not familiar with I think some of this audience knows what that means. It's sometimes been called first-class disk. But the older releases of VMware closely coupled the hypervisor volumes to individual VMs. Later, vSphere was re-architected so that it was possible to define disks completely independent of these VMs that could potentially be handed off from one VM to another and be a little more full-featured. So the CSI for vSphere is architected to use these first-class disks. It does mean that some of the ancient releases of vSphere can't go there. And maybe at the end of this, we'll have an audience poll of what releases of vSphere you guys are on now and are interested in. But we wanted to move to this because it allows certain flexibility benefits. This storage driver can also allow you to take advantage of Kubernetes zones. Kubernetes zones are a feature of Kubernetes where you can intentionally take your worker nodes or clusters and have them straddle across availability boundaries. And of course, the vSphere hypervisor has DRS clusters that were designed to do that as well. But you want a situation where you can make the declarations of what your availability zones might be in the underlying implementation so that the Kubernetes scheduler can do the right thing with regard to dispersing pods in an appropriate way for high availability. And since we're talking about stateful apps here, you know, the whole reason for using external volumes is to support stateful apps. Generally, availability is a strong desire. So we can support multiple vCenters, multiple data centers within one vCenter, multiple VMware clusters mapped into Kubernetes clusters. You can also provision these from data store clusters. We have right now support for both conventional and raw mounts. So if you're familiar, I think only the Uber geeks at this point are familiar with that distinction, so let me explain what that means. In the container world, a conventional mount goes and takes this storage volume and it's mapped right into the file system that you'd see from a Linux app. So it would be grafted into some point of your file system tree. A raw mount simply maps it as a device. And there are some database applications that would prefer, for performance or whatever reasons, to not deal with the file system layer within the Linux operating system and just go at raw device. And it is possible to do that. And I think I talked already about zone support. There's a link here, and this deck, at the end of the talk today, I'll publish a link to the deck, but you can find the link to the CSI driver here. The roadmap. Right now, I was talking about the features in CSI today. Roadmap for the rest of the year, this is second half of 2019, possibly later. We're looking at supporting resizing of already provisioned volumes. You can't do that today. That was a recent enhancement to the CSI spec, so normally the CSI spec gets enhanced and it takes a while to catch up with things that are exposed there, so we're planning on supporting the resizing. There is an effort now within the Kubernetes storage SIG to support snapshots. Now, granted, if you're familiar with the way vSphere operates, snapshots are built into vSphere, but it takes some work to put that, to expose that into a completely cloud agnostic wrapper, so that no matter where I'm hosting my Kubernetes, a public cloud or on vSphere, it all works the same. So there's an effort to standardize an API related to snapshots. And what this will enable is a better backup story. So if I'm running something like a Postgres database server on Kubernetes, there are ways to back it up by copying the storage to secondary storage. But if the underlying hardware supports a hardware snapshot, it sometimes can be faster and less impact on production workloads to have the back-end hardware trigger a hardware accelerated snapshot and then trigger the copy to secondary storage off of that. There's also work underway to send signals to applications so that they can quiesce. So as part of that backup story for stateful apps, many, if not most or all of them, will have caching going on in memory ahead of it getting flushed down to the underlying storage. Often there's 3 tiers of this, where a database server might keep at least indexes up in RAM, and they have in the background lazy attempts to flush that down to disk storage. It would go down to the Linux file system, and then maybe there's a third layer where you need to f-sync the Linux file system to really get a consistent recoverable state onto the disks or onto the volumes in this case, where things will be copied to your secondary storage. So work is underway to support that all the way through the APIs down to the underlying storage provisioning, and this is part of the roadmap. Also on the roadmap is support for read-write many volumes, so that you could have things in multiple pods all sharing that storage read-write, and today that isn't supported. Volume cloning, this is probably towards the back end of the roadmap, I think, but just because people are looking at it, and this is an expansion to CSI and the storage roadmap within Kubernetes. Also handling in-tree to CSI migration. So the Kubernetes storage SIG has a goal with regard to migration where at some point when the cutoff date is reached, where we're going to kill the in-tree Kubernetes storage plugin, the goal here is that we think we can we can replace the existing in-tree code with code that simply calls out to the CSI driver, so that if we can pull this off, the migration story for you, the user, is you don't really have to do anything. You could keep you could keep operating under the illusion that you're using the in-tree, and there is a stub bit of an in-tree driver that is simply going to go out and invoke the out-of-tree CSI code. And I think this is aspirational at this point, but nobody has come up with a theoretical reason why it shouldn't work, but it isn't implemented yet. So thus it's on the roadmap. This is an eye chart where, sorry, but these links are long and you'll get a link to the big deck afterward, but I just wanted to leave you with links for where you can find what I'd say, I'll call this a curated list of documentation. Some of these are official Kubernetes documentation. Some of this, since the storage provider was out of, if the storage provider is out of tree, the docs aren't necessarily found in alongside Kubernetes itself. So once you get used to it, you can find these, but this is just some links. The bottom one is very good and at a funny place because Miles here wrote an improved form of the documentation, and he's got it out at this location for review, and we haven't replaced the official docs with this, but it's a very good source. There is a link back 2 slides. I see Cormac in the audience, but he actually wrote a great blog article explaining first-class disk, which is a key element of what's going on in the new CSI driver. So if you don't even know what it means to have disks defined independent of the VM, I'd highly recommend that article. We've got interaction going on with pod scheduling and zones. Oh, sorry, come on over.
Don't worry about it. Can you guys hear me? Cool. Okay, so. Sure. Are you going to do it?
No, I'll hold it for you.
Okay, wow.
David's going to give a demo, so he needs keys-free, hands-free for the keyboard.
So as a part of the demo, I'm going to do it live over the internet, so nothing could possibly go wrong with that. So yeah, right here we have 2 components that we're going to deploy. I just wanted to call them out. And then especially for the first one, to have a link to its GitHub page so you know where it is and where the documentation lives. The first one is the vSphere Cloud Controller Manager. So you need this in order to support the zones first, and then also second, because the CCM, the Cloud Controller Manager, actually participates in the labeling of things out there in vSphere land. So you're going to need that. And then obviously the second component, because this is what the talk is, it's the vSphere CSI driver. So with that, instead of talking about it and showing you all the cool little notes for how to install it, we're just actually going to go ahead and do it. So I have my already logged into my master node here, and I'm already logged into my vSphere environment. So what we're going to do is we're going to deploy a stateful app, so basically a pod that's going to provision a disk and attach it to that pod so that we can have a stateful workload. It's going to be a very simple pod. It's not going to be complicated. But I wanted to basically first start by taking a look at the environment. So I kind of made on purpose. Yes? Yeah, good question. So vCenter and the ESXi are 6.7U2 right now in this demo. So I have 2 vCenter servers. The first one's shown here and has a single data center attached to it. And it has the Kubernetes master and 4 worker nodes. And if we look over here where my cursor is, it's tagged currently with the European region, and then the zone is European all. I just basically threw everything in there into the European all region. And then I have a second vSphere or a vCenter server. Now this one has 2 data centers. So the first one here, a little slow, but it's okay. The first one here is in the region US, and then the zone is US West. And it has 3 worker nodes attached to it. And then I have a second data center in this vCenter server in region US, and then zone US East. So the first vCenter server is in Europe. The second vCenter server is in the US. It has 2 zones, East and West. And so the first thing we do is, because we need to basically have a way for our pod to land in the correct region. And this is basically done by using the vSphere Cloud Controller Manager, so the vSphere CCM. And I'm going to just basically copy and paste a whole bunch of YAML So this YAML, you can actually go in the Cloud Controller Manager repo. So I believe it's github.com/Kubernetes/Cloud Controller Manager vSphere. And it's in the manifest folder. You can just download it all. The first thing you're going to need to do is update this YAML called secrets, which is basically going to store your vSphere creds, or your vCenter server creds, for both vCenter servers, right? Because I'm using 2 of them. And then update, the second one is a config map. Basically, you're going to need to tell Kubernetes about some configuration information like data centers to the Cloud Controller Manager. And what we're going to do, and the rest basically does roles, role bindings, and then deploy the Cloud Controller Manager. So I'm just going to do that really quickly. Hopefully all of this will work. First go into the CCM folder. Already have all the YAML there because I downloaded it earlier. All right, and if we do really quickly, all right, so there we go. vSphere Cloud Controller Manager right there in the center. So that got deployed successfully. So that takes care of our zones for pod placement and the labels. The next thing we want to do is if we want to provision storage, we need to deploy the vSphere CSI driver. So just like before, what we need to do is, if you have, your vSphere creds or whatever, you're going to need to update the secret. And then it's actually the same configuration file. So you need to you can use the same one, or you can create a whole separate one if you want to have, your own way of doing things. And then next, it's going to deploy all of the CSI components that are required for the vSphere CSI driver to work. So there's an attacher component that does a listen to basically attach the first class disk, or the VMDK, to the pod. There's a provisioner that actually will provision the pod. Then you have the RBAC for the controller component. Now that controller component is the one that does the actual creation, attaching, and all that stuff. Then the next one is the node daemon set, which basically, when you deploy that, it gets deployed to every node in your Kubernetes cluster, so that can actually do the volume mounting. And then after that, we have, the first ones are provisioner, attacher, RBAC, and then the actual deploy the provisioner and the attacher. So what I'm going to do is quickly copy and paste this down. It'd be cool to go into the CSI folder. And I'm just going to, and it's already been downloaded from github.com/Kubernetes/SIGs/vSphere CSI driver, I believe. Don't worry, the links are in the doc. You can download it later. I'm just going to paste it here. And hopefully all that stuff will get created. Okay, cool. So attacher controller, all the node components, and the provisioner. So now we're ready to deploy our stateful app. But before we do that, right, we need to first create a storage class and a persistent volume claim. And I just wanted to do just to call out what that storage class looks like. And the reason why is we want to, because we have multiple data stores or data store clusters spread out throughout the virtual infrastructure, what we need to do is what we're going to attempt to do is drop a pod, a stateful app, in the US East region. So it's basically the second vCenter server, the second data center that I talked about. And we're going to deploy a stateful app there. The problem is if we want to provision storage out of a particular data store, and the one that we're actually going to target, if we look at the storage view, is we're going to target this iSCSI-1 cluster in that data center. And so if we want to actually target the storage provision and the attachment of that first class disk or that VMDK, we need to give the CSI driver basically a hint saying we need it to be created here. And that's done in the storage class right here. So if we look at it, storage class is the kind, for vSphere FCD, blah, blah, blah. So parameters, data store cluster, because we want to target a data store cluster and not a data store. And then the actual data store or cluster name itself, so iSCSI-1 cluster. And then here's where we can actually target where we want to actually provision that volume out of. So basically, we want to do region US, and then zone US East. And that's how we're able to basically give the CSI driver a hint where we actually want to deploy that thing. And I'll just quickly take a look at the PVC just so that we can note here that we're going to create a 5 gig disk. So let's go ahead and create the storage class and the persistent volume claim. Awesome. All right, now the last, hopefully, thing that will work. We're going to actually provision a pod with using that storage, right, to create a stateful app. Now we're going to take a look at the pod spec here. So it's a simple pod spec. Pod, I'm just calling it my CSI app. We're just going to use the BusyBox image because it's easy and it's quick. We're going to mount it to /data. It's using that myFCD volume. Now we provided topology information to the storage class in order to provision the storage at a particular data store. But why we need to have this information also on the pod spec is basically when we want to actually land that pod, we need to land that pod in that particular zone to match with that, where that storage is being provisioned out of. So here you can see US, region US, zone US East, and here we're using that volume claim that we had created. And so let's go ahead and do that. And hopefully, magically, all this should work. Cool. Take a look at, do get all pods. So you can see right here at the top, the very first line, my CSI app, the container is getting created. And hopefully it should be created. And so it's running, and hopefully everything is good. Now the next thing we're going to do is take a look really quick. We're going to describe the pod, my CSI app.
Yeah, two B's there.
Insider joke, my B key sticks. Alrighty, so we did basically a describe on the pod, and we see that everything was created successfully. We see that the volume attach happened, awesome. And then if we take a look at basically the rest of the information for the describe, we see that the actual mount for my FCD volume was actually mounted to /data. Cool, so that's good. And it's running, awesome. And we also want to take a look to see where it's actually been targeted, right? So we wanted to throw it in US East, in that zone. And so we notice here, if we look at which node that this pod was actually deployed to, it was deployed at Kate's worker 9. And just to prove that everything worked great, we're going to go back to the host and clusters view, and we're going to go to worker 9. And if we do an edit of that VM, that virtual machine, we should see a 5 gig disk attached to it, and that is the hard disk number 2. Cool. So yeah, I just wanted to basically, I think it's better to see it actually happen in person so that we're not smoke and mirrors kind of a thing. And so yeah, that's basically a good demo about how you can deploy a stateful app using both the Cloud Controller Manager, remember, for the zones and then the tagging, and then obviously the CSI driver to provision the storage and make sure it gets created in the right place. And with that, yes, it worked. So for troubleshooting, there's a lot of information here. You can download the slide deck afterwards, but if you need help with any of this stuff, obviously go into the Kubernetes Slack. You can go to sig-vmware. I'll be there. I'm always hanging out. We have a bi-weekly SIG meeting for VMware, the VMware SIG. You can definitely stop by and ask questions there. Everyone's welcome, users, a vSphere, and all that fun stuff. And then obviously if you encounter any problems, the GitHub page is there where you can create issues, and we can answer any questions, or if you run into issues, we can hopefully resolve them and that kind of stuff, or even new features. So for debugging, debugging and logs, I just wanted to point out some really important areas you might want to take a look if you do happen to run into problems, like if you want to provide logs to make our lives easier. So the controller node, just kind of as a recap, you can basically, if I went back to the screen, back onto my master node, I can do a kubectl, and this is like the command you would use in order to get the logs for the controller. So the controller portion of the CSI driver is the one that actually does the, volume create, volume delete, volume attach, volume detach, and then if you want the node, so the node right gets deployed again to every node in the Kubernetes cluster because it's the one that's actually responsible for doing the volume mount for that particular VM. So if you want to get the logs for that particular node, you can basically go run that command, but be sure to target. And the reason why it says random right here in the middle is because per node, it's going to have a little random unique key, right, so that it can be uniquely identified to what host you actually want to pull the logs from. And then same with the CCM. The first command here is to show labels. The second command is to get logs. And then maybe every once in a while on a blue moon, some of the sidecar containers like that attacher and provisioner, you can get logs in a similar fashion, but just to let you know that they're there and they exist. And I didn't skip a slide. Okay, there we go. Perfect. You want to take it or want me to?
Go ahead.
Okay. So we talked briefly about like the migration from legacy CSI, or the legacy entry provider to the CSI for vSphere. So there is a process that's currently being worked on. It's not there yet, but we'll have a more formal process around the time of GA. So that was around the July timeframe, and we'll have, if you have any questions about that regarding that, you can definitely stop by Slack, and we'll be happy to answer any questions. But it is still currently in development because there is that like one-ish year gap where the entry provider is going to be deprecated. It's still being worked on, and there's still enough time to work through that process and stuff like that. So I will say that the migration will be tricky, obviously. So the entry provider uses just plain vanilla VMDKs, and then the external CSI drivers uses first-class disk. The first-class disk feature, just to really drive this point home, wasn't introduced until vSphere 6.5, and that there are many caveats about what features are available, but between the vSphere versions since after 6.5. So as an example, vSAN wasn't introduced until 6.7 I believe, or 6.7, and snapshots for vSAN I don't believe are available until 6.7 So things like that, they're little caveats that you need to be aware of. And like the full featured support for the CSI driver when this thing goes GA, it will be 6.7 so, or higher, right? But
maybe, David, let's take an opportunity here because there are different feature sets. We'll get to Q&A in a moment, but I want to ask a question to the audience as to what versions you might be on.
Time for feedback.
Yeah. So if you're on something older than 6.7, could you raise your hand?
So that's ESX host and vCenter server, by the way.
So I'd say that's 10 to 12. Maybe some people have small hand raises. So I gather, just to prove my point, the rest of you, if you're on 6.7, raise your hand.
6.7 or higher. Yeah.
So if full feature set is 6.7 how many people are willing to start using 6.7
So to repeat it, how many people are willing to start using 6.7 to get more features? We got a couple who aren't willing.
Okay.
Okay, thanks, Sue.
Yeah, feedback's good, definitely.
Okay, go back. You had personal recommendations?
So if you want to try to attempt to move now, I wait for a migration path and some more guidance. If you want to kick the tires to try to do a migration on your own, the safest thing to do, and I'm just floating the idea out here, stand up in the exact environment, and you can do it. Just an idea if you just want to kind of kick the tires, if you want to attempt to do a migration, and I'm not saying this is a good idea or bad idea, but at least it's the safest idea, is stand up a 6.7 environment somewhere else. You can use basically the in-app, hopefully whatever stateful application you have has some sort of replication feature. You can replicate the data to your other new cluster using 6.7, U2 or whatever, and then if everything else checks out, then you can basically switch everything over. And that is legit the safest way you could possibly do it. That's just a personal recommendation. Because if anything goes wrong with your new environment, you have your old environment you can always not switch over to, and it's still there, and it's still completely functional. And no one ever gets it right on the first time, and if you need 3 or 4 attempts, because you have your old environment, you can always make those 3 or 4 attempts until you get it right. And it's the safest route. That's just a personal recommendation from me. There will be a more formal process when it comes out, but I just wanted to float the idea out there in the interest of community and kind of like what I think is safe. But that's just my personal recommendation.
Okay, so thank you. Here's our contact information, a link to the deck up there if you want to take a picture of it. That deck also got uploaded to the conference website, so if you don't have your camera ready, just go onto the schedule and there's an uploaded copy of this deck there. If you want, we have this VMware SIG that meets, so that if you go home and try to do this and have any issues, I'd encourage you to get involved with the VMware SIG. It meets every 2 weeks with a Zoom meeting. We have an active Slack channel as well, a somewhat less active mailing list, and go out there and reach out to us. I guess that's about it. I'll open it up to questions. Anybody want to raise anything? Yeah, let me bring you the mic.
I'll run it back there.
So I was wondering more about monitoring these first-class disks. Will vSphere or the CSI driver provide something, pull out some metrics, make it possible for me to get an alert when the disk is about to become full?
I think I'll leave that to you, David.
So there are definitely, tools out there, a part of the vSphere, ecosystem. So there's Wavefront that can, basically hook into Kubernetes and say, grab metrics and stuff like that. I personally haven't used Wavefront enough to know whether or not that'll actually give you the information. I'd have to believe that they would put that in there because I hear that question a lot. So I would imagine that you could set up some form of alert or something like that to say, hey, this disk is starting to approach full. We need to do something about it. So, but yeah, if you want to stop by the VMware booth, definitely talk to there's some guys out there that are a part of it, and you can definitely get more information. And if not, I can. Oh, yes, I forgot. There is a Wavefront booth, so definitely stop by their booth.
He's one of the devs working on this. Anybody else got a question? There we go.
What about acquiring existing VMDKs into your Kubernetes environment?
I don't believe that's an easy act, the way that the underlying storage plugin works. You may be able to end up there by first deploying one and copying it somehow, but Kubernetes itself was designed to abstract that kind of thing out, and kind of the best practices ways of even consuming storage would not have you do things like hard coding a specific data store, much less a volume. The right way to do it in your pod spec is to specify a storage class, which is pretty broad. So I would say that would probably be best handled at an application level of composing something and perhaps copying it over or swapping it out. Okay, Glenn?
Hey, Vlad. Not to put you on the spot.
What was the question? Inline volume?
Oh, he wants to know if suppose you had an existing volume with data on it, could you end up mapping that to a Kubernetes pod? Am I correct? That was essentially your answer, your question?
Yeah, I mean, we have inline volume now, but inline volume right now is for ephemeral data.
We've been cut off.
So,
10 minutes over, 10 minutes over.
so that could be a
Okay.
path to
Okay.
I mean, I would like to find out more on the context of how that data would be used, but inline volume would be something to consider, and also local storage as well.
Okay, we've got another speaker waiting for this, but we'll move to the hallway, so feel free to come out and ask whatever you want. We can hang around.